Let's work on understanding the concept of absolute values better together. For number 1, let's go ahead and talk about what the absolute value of a number even represents. In short, the absolute value of a number is really just a number's distance from 0. Here's a couple examples to look at. So if we had the absolute value of 7, so these bars around the 7 mean the absolute value of it, this is really just saying how far is 7 away from 0. Now 7 is 7 units away from 0, so we would just say this is equal to 7. Now in another instance, if we had the absolute value of negative 8, this just means the absolute value of negative 8, or how far is negative 8 from 0, and that's going to be 8 units away from 0. So no matter if it's positive or negative on the inside of these bars, their absolute distance is always going to be a positive value. While the absolute value of positive numbers and negative numbers are always positive, there's one number where it's not, and that's going to be 0. The absolute value of 0 is equal to 0 because it's 0 units away from itself. For number 2, the question is, why does negative 7 3/4 and positive 7 3/4 have the same absolute value? Now if we think about it, if we go ahead and find the absolute value of negative 7 3/4, that would be a negative number, but it's just to the left of 0. Now the absolute value of that is just going to be positive 7 3/4. And then if we go ahead and take the absolute value of positive 7 3/4, you're going to find that that's also equal to 7 3/4, or positive 7 3/4. If you look at this on a number line and we go ahead and put 0 right in the middle, then the value of this negative 7 3/4 would be somewhere to the left of 0. I'm just going to plot it right over here, just a rough sketch. And then we can also maybe plot positive 7 3/4 to the right. That's going to be 7 3/4 to the right of 0. So while this negative 7 3/4 is to the left of 0 because it's negative, and this positive 7 3/4 is to the right of 0 because it's positive, we can still see that the distance from negative 7 3/4 to 0 is equivalent or equal to the same distance between 7 3/4 and 0. In short, negative 7 3/4 and positive 7 3/4 have the same absolute value because they are opposites. Here's number 3. For number 3, we're going to go ahead and write these in absolute value notation and then evaluate it. So we have the absolute value of 15. Now to go ahead and write that, we just go ahead and write these bars around the 15. We read that as the absolute value of 15, or how far is 15 from 0, and that's going to be 15 units, so we can just write 15. For number 4, we have the absolute value of negative 27. So in math, we can go ahead and write that with negative 27 inside these bars. We read that as the absolute value of negative 27, or how far is negative 27 from 0, and that's equal to 27. For number 5, we have the absolute value of negative 3½ Go ahead and put those bars around this negative 3½ so that's how far is this from 0. That's going to be positive 3½ units. Remember, we always measure units of distance as a positive value, not a negative value. For number 6, we have the absolute value of positive 4.8. So just go ahead and draw those bars, put 4.8 on the inside, and you read that as how far is this from 0, and that's going to be 4.8 units away from 0. For number 7, we have the opposite of the absolute value of negative 5, so this one's a little bit trickier. Now remember, opposite just means negative, so we can put the negative sign on the outside, and absolute value of negative 5, we go ahead and put that negative 5 on the inside of those bars. Now if we think about it, what's the absolute value of negative 5? That's just going to be positive 5, and so we have the opposite of that, which is going to be negative 5. Okay. For number 8, we have the opposite of the absolute value of 9.4. So again, opposite just means negative. Absolute value means we're going to go ahead and put these bars around this 9.4. So how far is 9.4 away from 0? Well, it's 9.4 units away, but you can see that negative's on the outside, so it's going to be the opposite of that distance, so negative 9.4. For number 9 on, let's go ahead and write the absolute value of each of these rational numbers. Remember, rational numbers are just fractions or decimals, as long as they can be written with a pattern, and not anything that's irrational, maybe like pi or e or any of those square roots of non-perfect squares. Then we're going to go ahead and plot each of these numbers on a number line real quick. Just a rough sketch though. So for number 9, we have the absolute value of 7, and that's just how far is 7 away from 0. We can just write that's equal to 7. So we're going to go ahead and draw a quick number line, and since we're talking about a positive number like 7, we can go ahead and put 0 over here to the left side, and then since 7's not too big of a number, we can just put some tick marks here. So this would be 1, 2, 3, 4, 5, 6, and 7. And then we're going to put a 7 over here. And just looking at the distance here between 7 and 0, we can see that the absolute value of 7 would be 7 because it's 7 units away from 0. For number 10, we have the absolute value of negative 13, so that's how far is that from 0, and that's just going to equal positive 13. Because we have a negative 13 for this problem, let's go ahead and put 0 all the way to the right side so we have some space to plot negative 13 to the left of it. Now, I don't really want to put 13 little lines, so let's maybe say each of these are worth 2. So this would be negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, and negative 14. So maybe let's go put negative 14 over here so we can see that we went by 2s. And so if we go ahead and plot maybe where these are, I guess even in number 9, I should put a dot on the number line to show where 7 was. So in this case, where's negative 13? Let's go ahead and plot it here. That would be between negative 12 and negative 14. Okay, now showing that the absolute value of this is indeed 13 units, you can see here that from this distance all the way to 0, that the absolute value of negative 13 would be positive 13 because it's 13 units away from 0. Let's try a few more. For number 11, we have the absolute value of 3.5, so how far is that from 0? We're going to go ahead and say that is going to be 3.5 units away. Since we had a positive value, let's go ahead and put 0 somewhere to the left side of the number line so we have some space. And let's see, let's go ahead and say that 3.5 is not too big of a number, so maybe make this 1, then 2, then 3, then 4. I don't think we have to go much further than that, just because 3.5 is smaller. So I'm going to go ahead and put the dot of where 3.5 would be on this number line. You don't have to go ahead and label every single tick mark on there if you don't want to, as long as it's clear where you put a number on the end so we can figure out what we skip count by. And so the distance from this 3.5 to 0, we can see the absolute value of that is going to be 3.5 because it's 3.5 units away. For number 16, we have the absolute value of negative 4 3/4. So how far is that from 0? Well, that's just going to be positive 4 3/4. Nothing too crazy here. Putting this on a number line, we had a negative 4 3/4. So let's go ahead and put 0 all the way to the right side so we have space. Then maybe let's go by 1s because these aren't, doesn't have to go too far. We just have to go to negative 5. So here's negative 1, here's maybe negative 2, negative 3, negative 4, and negative 5. So if we go ahead and put a negative 5 right over here to the left, then where would negative 4 3/4 be? Well, negative 4 1/2 would be here. I'm thinking negative 4 3/4. That should be pretty close to negative 5. So maybe something like this. Okay. Now, if it's a little confusing, I'll go ahead and just put this negative 4, negative 3, negative 2, negative 1, and 0. So maybe you can kind of see where the halfway mark is. So I'm thinking maybe that's half, and then this would be a quarter, right? So if you wanted to go ahead and put additional little tick marks in between here to show your quarters, maybe that'll help you, but totally up to you if you want to add in those details or not, okay? If you want to see the distance between this value and 0, we can see that the absolute value of negative 4 3/4, or how far it is from 0, is going to be positive 4 3/4 units. For number 12, we have the absolute value of negative 3.84, or negative 3 84/100ths. And so that absolute value, or that distance from 0, is just going to be 3.84. Looking at this on a number line, we have a negative 3.84, so let's go ahead and put 0 somewhere over here to the right. Maybe we only have to go to negative 4, but we have to estimate where this decimal would be. But maybe here's negative 1, here's negative 2, here's negative 3, and then maybe here's negative 4. Okay, so these would be maybe each of our integers, but where's negative 3.84? Well, that's going to be closer to negative 4 than negative 3, so I think it's maybe somewhere over here. Again, it's okay to estimate a little bit here, just making a rough sketch, and then we can go ahead and say that is going to be 3.84 units away, so the absolute value of negative 3.84 would be equal to positive 3.84. Now I know I'm going a little bit out of order here, but I'm going to go over to 17 to the right. So in this case, if we take a look at the inside of this absolute value bar, this says that we have a negative 4.5, but keep in mind that we can also think about that as the opposite of 4.5. Now the opposite of a number is just its original self, so we can say the inside of this simplifies down to the absolute value of just a 4.5, and so the absolute value of 4.5 is just equal to 4.5. Okay, so if that was a little confusing, keep in mind that two opposites equals the original, so we really just have 4.5 here as the absolute value. Now since we really just have a positive 4.5 on the inside, let's go ahead and put 0 to the left here since we're dealing with a positive number, and then feel free to write these numbers in or not, but I'm going to put 0, 1, 2, then 3, then 4, and then 5. And so we can maybe see where the 0.5s are, where the halves are, so this would be half, 1.5, 2.5, 3.5, 4.5. So if that's easier to follow, then great. I'm gonna go ahead and put a dot here at positive 4.5, and we can see the absolute value of that would be 4.5 just because that is the distance between 4.5 and 0. Let's check out number 13. For number 13, we have the absolute value of 4 3/5, so the distance from 0 is just gonna be positive 4 3/5. Now we're dealing with a positive number, so let's go ahead and put 0 all the way to the left. We only have to go up to 5, so let's make this 1, then 2, then 3, then 4. Let's put 5 over here. And let's see, we're talking about fifths here. 3/5 is a little bit more than a half of a box. You can divide these all into fifths if you want, but if you can estimate a little bit more than 4.5, I think that is good enough. And so we can go ahead and say that this distance from here to 0, visualizing that can just help us understand a little bit deeper and a little bit more clear. So we can see that this is going to be the absolute value, and that is 4 3/5 units. Now for number 18, this one's a little bit tricky because we have an absolute value bar on the outside. Now what's the absolute value of negative 2.5? Well, that's just gonna be positive 2.5. So we can go ahead and write that positive 2.5, but this extra negative that we see on the outside, that one doesn't get affected by those absolute value bars. So if it's on the outside, it doesn't get affected and it just gets tacked on to our final answer. So this is what this negative 2.5 represents. Keep in mind that when we see these bars around this negative 2.5, that's saying how far is it from 0, but this negative on the outside is saying let's find the opposite of that distance, right? So we do know the distance from 0 is 2.5 units, but we're saying this is the opposite of that distance. Again, our original value was negative 2.5, so we can go ahead and plot that on the number line. Let's put 0 to the right. Let's make this negative 1. Let's make this negative 2, and finally make this negative 3. So where's negative 2.5? Well, we can divide these all in halves. That's easy enough to do. And so here is negative 2.5, right? Now, if you wanted to see the absolute value of that, you can see that it is indeed 2.5 units away from 0. So that is the absolute value of negative 2.5, right? Now, why was our answer negative 2.5? Well, we had an extra negative there. So when we go ahead and put the negative on top of that, then we have the opposite of the distance would be negative 2.5 or negative 2.5. For number 14, we have the absolute value of negative 3/4. That is just going to be 3/4 away from 0, so we can just put it just like that. And now let's make a number line. We're dealing with a negative 3/4, so let's go ahead and put 0 all the way to the right here. And we can also do something like this where we can just make this negative 1, right? That way we can see that we have negative 1/2 here. If that's a little bit more clear, this would be negative 1/4 and negative 3/4. So if we want to write that in, we can also do that just to make it super clear. So that is the type of number line you could also create here. And then we can go ahead and put a dot over at negative 3/4. You can see that this distance from here to 0 is going to be 3/4 a unit. So that's the absolute value, right? That's what we're trying to show here. For number 19, we have the absolute value of this 4.9. So how far is that from 0? And that's just going to be equal to 4.9, right? But then we have this negative that's on the outside of it. So that's saying what's the opposite of that distance? Now the opposite of 4.9 is just negative 4.9. Now the original value we were dealing with was a positive 4.9. So let's go ahead and put 0 all the way to the left here. This would be 1, this would be 2, this would be 3, this would be 4, this would be 5. Go ahead and put that right over here. And where would 4.9 be? Well, 4.9 would be really close to 5, so we can go ahead and put a dot all the way to the right here, pretty close up to it. So if we go ahead and show the distance here, this would be the absolute value of 4.9. So that is 4.9 units, but again, this extra negative on the outside means that we're gonna have a negative value for our answer. But again, what was inside the absolute value bars was the 4.9, and so we're showing that original number and its distance from 0. Last couple here, let's check out 15. For 15, we have the absolute value of negative 4.2. That's how far is that from 0? That's just equal to positive 4.2. Let's go ahead and make a graph to show this. Now this is a negative 4.2, so we can go ahead and put 0 all the way to the right side so we have space for this. So here's negative 1, here's negative 2, here's negative 3, here's negative 4, and here would be negative 5. All right, so we went by ones here. Where would be negative 4.2? That's gonna be right around here, right? It's gonna be a little to the left of negative 4, but not too far, not like negative 4.5 or anything, right? Now, if we're going to go ahead and see this distance from 0, we can see, oh yeah, that does look like it's 4.2 units away. That's the absolute value of negative 4.2. And finally, for number 20, this one looks a little bit scarier, but we need to make sure we understand what's going on inside here. It's what's the distance from the value inside here from 0. Now we have a 4 7/8, but then we have the opposite of it. Now, we said this a little bit earlier, but what's the opposite of the opposite? The opposite of the opposite is just the original, okay? So we really have just a 4 7/8 in there. We can get rid of those two negative signs or opposite symbols since the opposite of the opposite is original. And then so we just have 4 7/8, and so the absolute value of that is going to be 4 7/8, but then we have a negative on the outside, which means the opposite of that. So I know that was a lot of opposites, but this final answer to this expression would be negative 4 7/8. So again, this whole thing really is just the same thing if we simplify it to just a normal 4 7/8, because the opposite of the opposite is the original. And how far is this thing from 0? Well, it's 4 7/8 away. But then whenever there's a negative on the outside, it means we have to find the opposite of that final answer. All right, so for this final one, remember this whole thing inside here at the beginning was technically just this positive 4 7/8. So I'm gonna go ahead and put a 0 here. Let's put 1, 2, 3, 4, and 5, just like that. And so where would 4 7/8 go? Well, 4 7/8 should be really close to being 5. So I'm gonna go ahead and put that all the way pretty close to this 5. So we can see that this distance from 0, that's going to be the absolute value of that 4 7/8. I'm not going to put the negative just because it's the same thing, okay? So there you have a bunch of different practice problems dealing with absolute value. Hopefully you feel a little bit more comfortable about how to use the symbol and what it represents. It's easier than writing out the whole word absolute value every single time. And you can go ahead and see that each of these will get you some different values. They're always going to be positive. Unless we have a negative on the outside, then your answer is going to be the opposite of a positive, which happens to be a negative. So I hope you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.